In this session, we will be looking at past CAT geometry questions from CAT 2003 to 2008. So this first question seems like a difficult, complicated question, but we don't have to use all the information. We just have to find the ratio of AP is to PD. So we have to use this ratio of AP is to PB, and we have to use the information about parallel lines so that we use basic proportionality theorem. We will not be using 90 degrees and 6 centimeter. So first of all, if we use that PQ is parallel to AC, okay, and if you look at these two related triangles, PBQ and ABC, through basic proportionality theorem, now we have that AP is to PB is 4 is to 3. So if I take AP to be 4x and PB to be 3x, okay, so AP is to PB 4 is to 3. Now as per basic proportionality theorem, CQ is to QB will also be 4 is to 3. So let us take CQ to be 4y and QB to be 3y. Now we have another pair of parallel lines. We also have that QD is parallel to CP. So if you look at these two triangles, QDB and CPB, using basic proportionality theorem, CQ and QB are in the ratio 4 is to 3. So PD and DB will also be in the ratio 4 is to 3. So let us take PD to be 4z and DB to be 3z. Now, we can see that 4z plus 3z will be equal to this 3x. Okay, so we will get 4z plus 3z is equal to 3x. So 7z is equal to 3x. Okay, so we have this relation between z and x. Now focus on what we have to find. We have to find the ratio of AP and PD. Now what is AP? AP is 4x. Okay, and what is PD? PD is 4z. So let us express either x or z in terms of the other one. So we have 7z is 3x. So we'll get that z is equal to 3x by 7. And let us substitute that here. So this is 4x. And here 4z, z will be 3x by 7. So now what will happen? 4 will cancel off, x will cancel off. And we will, by multiplying both the sides with 7, we will finally get 7 is to 3. So the answer is option 3. If you look at this question, which is a question on heights and distances, there is a father and his son waiting at a bus stop in the evening. There is a lamppost behind them. The lamppost, the father and the son stand on the same straight line. The father observes that the shadows of his head and his son's head are incident at the same point on the ground. Okay, so, and then we have the heights of the lamppost, father, son, 6, 1.8 and 0.9 respectively. And father is standing 2.1 meters away from the post. Okay, then how far in meters is the son standing from the father? So we will get this diagram where this longest vertical line is the lamppost. Then the second longest is the father. And the smallest one is the son. And all of their shadows are incident at the same point. That point is P. Okay, so L is for lamppost, F is for father, S is for son. P is the point where we are getting all their shadows. Okay, where all their shadows are incident. Okay, it has been given that the father is standing 2.1 meters away from the post. So this will be 2.1. Now in these questions, what we have to do is we have to use similarity because all of these will be 90 degrees. Okay, because all of these are vertical and the ground is horizontal. So we'll have 90 degrees. And this angle will be common to all the right angle triangles. So all the 3 right angle triangles will be similar. And now we'll have to use similarity. So first of all, if you look at this smallest right angle triangle with the second smallest right angle triangle, okay, let's call it this way, that one of the right angle triangles is the largest one. One of them is the smallest one and one of them is the middle one. So if we look at the smallest one and the middle one, we can see that these are corresponding sides 0.9 and 1.8. So for the middle one, 1.8 is double of 0.9. So a corresponding side of the middle one will be double of the corresponding side of the smallest one. So for example, if I take this to be x, okay, if I take this length SP to be x, then this length FP will become 2x. Okay, this FP will become 2x. 1.8 is double of 0.9, so 2x will be double of x, which means Fs will be 2x minus x, which will be x. And now we just have to use one more similarity. So for example, if we use, let's say, the middle right angle triangle with the largest one. So the ratio of corresponding sides is 1.8 and 6. 1.8 divided by 6. And also their corresponding side. So for the middle one, we have this side of 2x. And for the largest one, we have 2.1 plus 2x. 2.1 plus 2x. Now this is the ratio of corresponding sides. This is also the ratio of corresponding sides. So they will be equal to each other. And now we just have to solve this to get x. So if we solve this now, we will get 12x. Now 2.1 into 1.8. What is 21 into 18? 378. So this will be 3.78. Okay, then we have 2x into 1.8. That will be 3.6x. Okay, so now solving this, we will get 12x minus 3.6x. That will be 8.4x. This is equal to 3.78. So x will come out to be 3.78 by 8.4. So that will be 378 by 840. Okay, now we'll have to simplify, calculate this. So if we cancel off with 2, we get 189 by 420. Now we can cancel off with 3. So we will get 63 by 140. We can cancel off with 7. So we will get 9 divided by 20. And 9 by 20 we can easily calculate. So 9 by 20 multiply and divide by 5. So we'll get 45 by 100, which will be 0.45. Option 4. If we take a look at this question, a vertical tower OP stands at the center O of a square ABCD. Let H and B denote the length of OP and AB respectively. Suppose angle APB is 60, then the relationship between H and B can be expressed as. So if we make the diagram, first of all, we will have a square ABCD. Now we will have a center O, and from the center, we will have a vertical tower OP. Now here you will have to visualize, because of course this is a 2D diagram. You will have to imagine it, that here we have a vertical tower. Here it seems like it is just on the ground, but it will actually be vertical up in the air. Okay, so this point will be up in the air, whereas points A, B, C, D will be points on the ground. Okay, so imagine that. Now we have angle APB is 60. So if we connect points A and B with P, then this angle APB is 60. Again, imagine that this point P is up in the air and A and B are on the ground. Now, point P, see, the tower is right in the center of the square. So it is in the center, and the square, all the sides are equal, all the angles are equal. So if we have this tower in the center, then this point P, the top of the tower, it will be equidistant from all the 4 vertices because it is in the center. So AP will be equal to BP. Now, one angle here is 60, so AP is equal to BP. So the other 2 angles will also be equal, and they will also come out to be 60. Sum of the 3 angles is 180. These 2 angles will be equal, so they will also be 60. Okay. Now what do we have? We have to find H and B. H is the length of OP. Fine. Now what is B? B is the length of AB. Okay, so let us try to find a relationship between H and B. So B is AB, which means B is the length of any side of the square. All the sides are the same. This will also be B. Now, how do we get a relationship between H and B? So this tower OP is H. Okay, and B is a side of the square. So what we can do is, if we connect points O and B here, okay, then we will get a right angle triangle, because this tower is vertical and this line OB will be horizontal on the ground. So we'll get 90 degrees here. Now we just need to express all the sides of this triangle in terms of H and B. So first of all, in this triangle APB, we can see that all the angles are 60. So all the 3 sides will be equal. One side is B. So this side will also be B. And if you look at this side OB, now BC is a diagonal of the square, and this OB will be half of the diagonal. Now, what is the diagonal of the square? It is root 2 into the side. So the diagonal of the square will be equal to root 2 into the side, root 2 into b. And therefore, OB, which is half of the diagonal, BC is the diagonal, O is the center. So OB is half of the diagonal. So OB will be root 2b by 2. So that will be b by root 2. Okay, b by root 2. Now we can use Pythagoras in this right angle triangle. So we can say that h square plus b by root 2 whole square is equal to b square. Simplifying this, h square plus b square by 2 is equal to b square. So we'll get that h square is equal to b square by 2, which will give us that 2h square is equal to b square. So we are getting this relationship between h and b. 2h square is equal to b square, which is there in option 2. In this question, it has been given that each side of a given polygon is parallel to either the x or the y axis. A corner of such a polygon is convex if internal angle is 90, concave if internal angle is 270. If the number of convex corners is 25, the number of concave corners must be. So let the total number of interior angles be x. I'll just write this down. Let the total number of interior angles be x. Now, we can find the sum of all the interior angles. What is the formula? N minus 2 into 180, where n is the total number of angles. So just replacing n with x, we can say that it will be x minus 2 into 180. The sum of all the interior angles, x minus 2 into 180. Now, we can break up this sum, the total, in terms of convex and concave. So for convex, we have 25 of them and each one is 90. So the sum of the convex angles will be 25 into 90. So this is for the convex. Now we will add the concave to get the total. Now concave, how many angles will there be? Total number of angles is x, out of which 25 are convex. So the remaining x minus 25 will be concave. And each one of them is 270. So the sum will be x minus 25 into 270. Okay, so the sum of the convex angles plus the sum of the concave angles, that is equal to the sum of all the interior angles. Now we just have to solve this. So to make the calculation easier, we can represent everything in terms of 90. 270 and 180, both of them are multiples of 90. So this will be 25 into 90 plus 270. So that is 90 into 3. Okay, so first of all, we can do 270 into x. With x, it is fine. But if you look at the numbers, minus 25 into 270. Now 270 is 3 into 90. 25 into 3 will be 75. So we will get 75 into 90. And here we will get 180 into x, 180x. Now minus 2 into 180. 180 is 2 into 90. So 2 into 2 into 90, which will be 4 into 90. Now, 270x minus 180x will be 90x. Now look at the other values. So here we will have 25 into 90 minus 75 into 90. 25 minus 75 will be minus 50. On the other side, that will become plus 50. And 50 minus this 4, that will give us 46. So 46 into 90. Okay, so now the calculation is very simple. Cancel of 90. So we will get x is equal to 46. X was the total number of interior angles. Okay, now what will be the number of the concave angles that we'll get? From the total, so if you're finding the concave ones, from the total of 46, we will subtract the convex ones, which is 25 in number. So 46 minus 25, that will give us 21. So the number of concave corners must be 21, option 3. In this question, there are two concentric circles such that the area of the outer circle is 4 times the area of the inner circle. Let A, B, and C be 3 distinct points on the perimeter of the outer circle such that AB and AC are tangents to the inner circle. If the area of the outer circle is 12 square centimeters, then the area in square centimeters of the triangle ABC would be. That's what we have to find. Let's make the diagram. Two concentric circles, one smaller, one larger, both of them have the same center. Now we have that the area of the outer circle is 4 times the area of the inner circle. So if we compare the areas of the outer one and the inner one, ratio of the areas is 4:1. Area of the outer is 4 times the area of the inner, 4:1. So now area of a circle is pi r square. So it depends upon the value of r square. So here the ratio of the areas is simply the ratio of the square of the radius. So if we want to find the ratio of the radius, we will take the square root of the ratio of the areas. Square root of 4 is 2, square root of 1 is 1. So ratio of the radius is 2:1. So let us take one radius, for example, to be, let's say, x, and therefore the other radius will be 2x. Okay, now let us complete the diagram. So we have points A, B, and C, 3 distinct points on the perimeter of the outer circle, such that AB and AC are tangents to the inner circle. So we are drawing 2 tangents from point A. AB is a tangent, AC is also a tangent. Okay, so we will get this kind of a triangle, where take any point as point A on the perimeter, on the boundary of the outer circle, then draw 2 tangents, okay, to the inner circle, and then just connect points B and C. Now, if the area of the outer circle is 12 square centimeters, then what is the area of triangle ABC? So first of all, area of the outer circle. Radius of the outer circle is 2x. Now area is pi into radius square. So we will have pi into 2x whole square. Area of the outer circle, so that will be equal to 12. So at least we'll get the value of x square in terms of a number and in terms of pi. So here pi into 2x whole square. 2x whole square will be 4x square. 4 will cancel off with 12, so we'll get a 3 here. Okay, and here we will be left with x square, and then pi will come in the denominator of the right hand side. This is very basic simplification. X square will be 3 by pi. Now we have to consider the area of the triangle ABC. Okay, so what can we do? We have the center, and we can see that we have tangents. So if we connect the center to the tangent at the point of contact, that line will be perpendicular to the tangent. Okay, so we can do this, okay, where we draw this radius here, this radius of the inner circle, which is x. Okay, and then we also connect the center to point A, so that we get this triangle, and this will be a right angle triangle. Okay, the radius to the tangent at point of contact will be perpendicular to tangent. Now, what is this? So if I take the center as O, what is this length OA? It is the radius of the larger circle, which is 2x. Okay, so that is 2x. Now, if in this right angle triangle, if we use Pythagoras, this hypotenuse is 2x, this perpendicular side is x. So using Pythagoras, we will get this side to be root 3x. Okay, if I name this point D, AD will be root 3x. And so we can see that the ratio of the sides of this triangle are 1:to root 3:2. Okay, we have the sides of the triangle as x, root 3x, and 2x. So the ratio is 1:to root 3:2. And we get this in a 30, 60, 90 triangle, where the 1 corresponds to the side opposite 30 degrees, root 3 opposite 60 degrees, and 2 opposite 90 degrees. Okay, so we will get that the side opposite x here, that will be 30 degrees. Sorry, the angle opposite x will be 30 degrees. And this remaining angle opposite root 3x will be 60 degrees. Now, there is one more property, that from the center, if we draw perpendicular to a chord, it will bisect the chord. So here chord AB will be bisected. Okay, so if AD is root 3x, DB will also be root 3x. Now, the same thing will happen on the other side with respect to the tangent AC. Okay, for example, if I show you the same thing. If I just draw the radius here, which will be perpendicular to the tangent, this radius is x. And AO we know is 2x. And now using Pythagoras, this, if I name this E, AE will also be root 3x. Okay, so again, we'll get that this angle will be 30. This angle will be 60. Same thing. And again, from the center, we have a perpendicular to a chord. It will bisect the chord. So since we have, this is root 3x, then EC will also be root 3x. Okay, so now what are we getting? We are getting that AB and AC are equal. AB and AC are equal sides of the triangle. Okay, both of them are 2 into root 3x. And opposite equal sides, we have equal angles. So angle B and angle C will be equal. Now, angle A is 30 plus 30, which is 60. Okay, so now if angles B and C also have to be equal, both of them will also be 60. So we can see that ABC will be an equilateral triangle. And what is the area of an equilateral triangle? Area of an equilateral triangle is root 3 by 4 into square of the side. So if we now calculate area of triangle ABC, it will be root 3 by 4 into square of the side. Now what is the side? Okay, AB, AC, both of them are 2 root 3x. BC will also be 2 root 3x. Okay, root 3x plus root 3x. And therefore, we will have the square of this. Square of 2 root 3x. Okay, so now when we simplify this, we will get root 3 by 4 into 2 square is 4, root 3 square is 3, and then we have an x square. 4 will cancel off. Okay, so we are getting 3 root 3 into x square. What is x square? X square is 3 by pi. So ultimately, we will get 9 root 3 divided by pi, which is there in option 3. If you look at this question, it has been given that the length of the circumference of a circle equals the perimeter of a triangle of equal sides and also the perimeter of a square. The areas covered by the circle, triangle and square are CTS respectively. And then we have to find which one is the largest, smallest, which one is in between. So now length of the circumference of a circle. Circumference is 2 pi r, where r is the radius. Okay, this is equal to the perimeter of a triangle of equal sides. Perimeter of an equilateral triangle. If you let the side of the equilateral triangle be A, then the perimeter will be 3 into A. 3 sides. And also the perimeter of a square. If you let the side of the square be x, then the perimeter of the square will be 4x. All of these are equal to each other. So to make it simple to find the relationship between the areas of the different figures, let's assume all of these to be equal to 1. Because ultimately we just have to compare. We cannot find any actual value. So let us assume all of these equal values to be equal to 1. So if 2 pi r is equal to 1, we will get that r is equal to 1 by 2 pi. Similarly, if 3a is equal to 1, we will get that a is equal to 1 by 3. 4x is 1, so x will be equal to 1 by 4. Now, let us compare area of circle, triangle and square. So if I just write it down, circle, triangle, square. Now, area of a circle is pi r square, pi into the radius square. So let's look at the ratio. That will be a good comparison. So area of circle, pi into r square, r is 1 by 2 pi. So pi into 1 by 2 pi whole square. Area of this equilateral triangle, root 3 by 4 into square of the side. So root 3 by 4 and side is 1 by 3. So into the square of 1 by 3. And then area of the square is square of the side. Side is 1 by 4. So we'll have the square of 1 by 4. Okay, so if we start calculating these and simplifying these now, pi into 1 by 2 pi whole square, that will give us 1 by 4 pi. Here, root 3 by 4 into 1 by 3 whole square, root 3 by 4 into 1 by 9. That will give us 1 by 4 into 3 root 3. So that will be 12 root 3. And here 1 by 4 whole square, that will be 1 by 16. How do we compare these? All the numerators are the same. So we just have to focus on the denominators. Whichever fraction has a larger denominator will be a smaller fraction. Okay, that is the logic we'll use. So let's get an approximate idea because we are only comparing. If you look at 4 pi, what is pi? Pi is 3.14. We can take it to be approximately 3. So 4 pi, 4 into 3, that will be approximately 12. So 1 by 12. Okay, now 1 by 12 root 3. What is root 3? Root 3 is approximately 1.7. So 12 into 1.7 will be approximately 20. So we'll get 1 by 20. And then here we have very simply 1 by 16. So if we first want to find out the largest value, largest of these fractions will be the one with the smallest denominator, which is 1 by 12, which corresponds to area of a circle. So circle area, which is C, that will be the largest. After that, okay, for the second largest, we will have to look at that denominator, which is in the middle. So 12, 20, and 16, middle one is of course 16, which is for area of a square. Okay, so next we'll have S. And then we'll have the last one, triangle. That fraction with the largest denominator will be the smallest one. So that is for triangle T. So ultimately we get C greater than S greater than T, which is there in option 3. Okay, in this question, a piece of paper is in the shape of a right angle triangle. It is cut along a line that is parallel to the hypotenuse, leaving a smaller triangle. There was a 35% reduction in the length of the hypotenuse of the triangle. If the area of the original triangle was 34, what is the area of the smaller triangle? Here, because this line along which we are making the cut, because it is parallel to the hypotenuse, we will get two similar triangles. Because this angle will be equal to this angle, corresponding angles, parallel lines. And similarly, this angle will be equal to this angle. Okay, so the smaller right angle triangle and the larger right angle triangle, they will be similar to each other. And we'll use similarity. If we get the ratio of corresponding sides, okay, then we can get the ratio of the areas. So if we look at the larger triangle with the smaller triangle, and if we compare their corresponding sides, so if I assume the hypotenuse of the larger triangle to be 100, okay, if I just assume it to be 100 in the ratio, then the hypotenuse of the smaller triangle will be 35% less. So that will be 65. 35% less than 100, so that will be 65. And of course, the hypotenuses are corresponding sides. Now, if we simplify this, okay, we are still looking at the corresponding sides. So if we simplify this by dividing by 5, we will get 20:30. And therefore, what will be the ratio of the areas of these two triangles? Ratio of areas will be the square of the ratio of corresponding sides. 20 square is 400. 13 square is 169. Now, this is a comparison of the areas. So let us take this area to be 400x. Let us take this area to be 169x. Now, the area of the original triangle, the larger triangle, was 34 square inches. And here we are getting 400x. So 400x is equal to 34. Okay, so x is equal to 34 by 400. And therefore, area of the smaller triangle, which is 169x, that will be 34 by 400 into 169. Okay, we can do this fairly manageable calculation to get approximately 14. Specifically, we will get 14.365. Option 4. If you look at this question, a square tin sheet of side 12 inches is converted into a box with open top in the following steps. The sheet is placed horizontally. Then equal size squares, each of side x inches, are cut from the 4 corners of the sheet. Finally, the 4 resulting sides are bent vertically upwards in the shape of a box. If x is an integer, then what value of x maximizes the volume of the box? So first we'll start off with the square. Okay, this is the square tin sheet of side 12 inches. Every side will be 12. Now, what are we doing? Equal size squares each of side x inches, we are cutting from the 4 corners. Okay, so let's say these are the 4 equal size squares that we are cutting from the corners. Each of side x inches. So this will be x, this will also be x. Now see, if this total was 12, 12 minus x will give this as 12 minus 2x. Okay, 12 minus 2x. Similarly here, if we have this 12 as the total, and if this is x and this is x, then the middle value will be 12 minus 2x. Okay, so now, how are we forming the box? So now, if we look at this part of the figure, this part will become the base of the box, the bottom of the box. And remember, we are cutting away the corners. So imagine that the 4 smaller squares at the corners. So imagine that the 4 smaller squares at the corners, they are removed. They have been cut away. So we will just have this part in the middle and we will have these 4 sides. So this middle part, that will become the base, the bottom of the box. And these 4 sides, they will become the 4 walls, the 4 lateral sides of the box. Okay, and the box will not have a surface at the top. It will be open at the top. So now, this base of the box, it is made up of length and breadth of the box. So we can see that the length will also be 12 minus 2x. Okay, and the breadth will also be 12 minus 2x. Okay, so we have length and breadth. Now we also need the height of the box for the volume. So height, for example, this will become a wall of the box, a lateral surface of the box. And therefore, this part, this will become the height. You have to imagine this. Imagine that this side, we are flipping it up. Okay, we are folding it up. And therefore, this part, which is x, this will become the height of the box. So if you are talking about volume of the box, the volume of the box is length into breadth into height. Now we have seen length is 12 minus 2x. Okay, breadth is also 12 minus 2x. And the height is x. Now we have to maximize this. And we have to find which value of x will maximize this. Whenever we have maximum or minimum, we can either think about am greater than equal to gm, or we can think about that when the sum is constant, then the product will be maximum when the values are equal. Okay, so if we try to use that, first of all, if we simplify this, 12 minus 2x, we can take a 2 common. And the other 12 minus 2x also, we can take a 2 common. 2 into 2 will give us 4. Now, after taking 2 common, we will have 6 minus x and 6 minus x. Now, 4 is fixed. Okay, we have to maximize the product of these values. 6 minus x into x. But if we look at these values, their sum will not be constant. If we add them up, we will not get a fixed number. X will still be there. And therefore, we have to do a little bit of adjustment so that we get a constant sum for them. So now what we can do is, we can see we have minus x, which is minus 2x. So to cancel off x, we will also need a plus 2x. Okay, so what we can do is from the 4, we can take a 2 and multiply it with this x. So from 4, 1, 2 will keep here. 6 minus x will be the same. And another 2 we will multiply with x, so that will become 2x. Now, if you look at 6 minus x and 2x, these 3 values, the sum, if you add them up, sum becomes 12, which is constant. And when there is a constant sum, the product of these values will be maximum when the values are equal. Okay, so for maximum product here, for maximum volume here, we will take 6 minus x to be equal to 6 minus x and both of them to be equal to 2x. When the sum is constant, the product is maximum when the values are equal. And therefore, if 6 minus x is equal to 2x, we will get that 3x is equal to 6. Therefore, x is equal to 2. X is equal to 2 will maximize the volume of the box. Therefore, the answer is option 4. In this question, 3 horses are grazing within a semicircular field. We have the 3 horses are tied up at the centers P, S and R. P is the center, P and R are centers of the smaller semicircles, S is the center of the circle, and O is the center of the larger semicircle. Okay, and we have to find the out of the total area, out of the area of the larger semicircle, what percentage of the area cannot be grazed by the horses. Okay, so we basically have to find this area as a percentage of the total area, because the horses can graze within the smaller semicircles and within the circle. So we have to find the remaining area as a percentage of the total area. Now, first of all, we can, let's say, assume the radius of the larger semicircle to be 2. Ultimately, we have to find a percentage. Let's assume a convenient value. Why will 2 be convenient here? Because if this is 2, then this diameter of the smaller semicircle is also 2. Okay, so this 2 we will have to divide by 2 to get the radius of the smaller semicircle, 1 and 1. Now similarly, this will be the radius of the larger semicircle, 2. And 2 will be the diameter of this smaller semicircle also. So the radius of this smaller semicircle will also be 1. Now we also have to find radius of the circle. So we will make this construction by joining the centers of the semicircles and the circle. And from the center of the larger semicircle, we will draw a line passing through point S in this manner. How will this help us? First of all, we'll get, first of all, if I take the radius of the circle to be, let's say, x, then from the radius of the larger semicircle, which we have taken to be 2, from the radius of the larger semicircle, if we subtract this x, then we will be left with 2 minus x. Okay, from the total radius of 2 of the larger semicircle, if we subtract x, then this part, that will come out to be 2 minus x. Now here we'll get a right angle triangle, okay, because this vertical line is tangent to the semicircles. So in this right angle triangle, this side is 1, another side here is 2 minus x, and now for the hypotenuse, this much is the radius of the semicircle, which is 1, this much is the radius of the circle, which is x. Okay, so this side of the triangle will be 1 plus x. So in this right angle triangle, if we use Pythagoras now, we will get 1 square plus 2 minus x whole square is equal to 1 plus x whole square. Okay, so let's use it. 1 square plus 2 minus x whole square is equal to 1 plus x whole square. So we'll get 1 plus 4 minus 4x plus x square is equal to 1 plus 2x plus x square. X square will cancel off. Here we'll get 6x and 1 will cancel off. We'll just be left with a 4. 6x is 4. So x is equal to 4 by 6, which will be equal to 2 by 3. Okay, now we have to find the area which will be ungrazed. So if we first focus on the total area, the total area will be the area of the larger semicircle. Area of a semicircle is pi into radius square by 2. So radius of the larger semicircle is 2. So pi into 2 square by 2. So that will be 2 pi. Okay, 2 pi is the total area. Out of this total area, what is the area that will be grazed? Area grazed will be the area of the two smaller semicircles and the area of the circle. Now the two smaller semicircles are identical. So when we combine them together, they will give us a circle. And both of them have radius 1. Okay, so we will get a circle of radius 1 when we combine them. Area of the circle will be pi into 1 square, pi into radius square. And now we also have to add the area of this circle. Radius of this circle is 2 by 3. So area of this circle will be pi into 2 by 3 whole square. So if we calculate the area grazed now, we will have pi plus 4 by 9 pi. That will be 13 pi by 9. Okay, so what will be the area that is ungrazed? We will get area ungrazed to be the total area of 2 pi minus the area grazed, which is 13 pi by 9. Okay, so that will give us 5 pi by 9. So we have to calculate this ungrazed area 5 pi by 9 as a percentage of the total area, which is 2 pi. So for percentage, we will multiply with 100. Okay, so when we calculate this, we will get 5 pi by 9 into 2 pi, which is 18 pi. and then into 100. Pi will cancel off. So we'll get 5 by 18 into 100. What is 1 by 18? 1 by 18 is 5.55%. So 5 by 18 will be 5 into 5.55%, which is approximately around 28%. So if we approximate, we will say that we are getting 28% here. And therefore the answer will be option 2. In this question, if the lengths of diagonals DF, AG and CE of the cube shown in the adjoining figure are equal to the three sides of a triangle, then the radius of the circle circumscribing that triangle will be. If you look at these diagonals, DF, AG and CE, we can see that all of these are diagonals connecting two furthest points of the cubes. We can see that all of these are basically body diagonals of the cube. All the body diagonals of the cube are equal. Now, what is a body diagonal of the cube? Body diagonal of a cube is root 3 into the side of the cube. How do we get that? So if we look at a cube, here for example, if we first find out DE. So if I take, let's say, the sides of the cube to be x, DAX, AEX, now we will get a right angle here. So in this right angle triangle DAE, if two sides are x, then the hypotenuse will be root 2 into x. Now let us look at another right angle triangle, which is DFE, where the right angle is at E. So here FE is x, which is the side of the cube, and another perpendicular side is root 2x. So by using Pythagoras, we will get DF to be root 3x. Okay, so we are getting that the body diagonal is root 3 into the side of the cube. Now the three body diagonals will be connected to form a triangle. The three body diagonals will give us the three sides of a triangle. So this triangle that we are talking about, each of the three sides will be root 3 into the side of the cube, root 3x. Now we want to find the radius of the circle circumscribing that triangle. First of all, this is an equilateral triangle if all the sides are equal. And therefore, if we want to find the radius of the circle circumscribing it, which is the circumradius of an equilateral triangle is side of the triangle divided by root 3. So here the circumradius, which let's take it as capital R, that will be the side which is root 3x divided by root 3. So we can see that the circumradius will be equal to x. So the circumradius will be equal to the side of the cube, and therefore the answer is option 1. In this question, we have two identical circles intersecting so that their centers and the points at which they intersect form a square of side 1 centimeter. The area in square centimeter of the portion that is common to the two circles is. Let's make the diagram. Two circles which are intersecting. We have to find this intersection area. And then we have a square. We are getting the square by connecting the centers and the points of intersection. Points of intersection are these 2 points. So by connecting these 4 points, we are getting a square. Now, side of the square is 1. So all of these are 1. So we can see that the radius of the circles are also 1. Okay, from center to circumference, radius is also 1. How do we calculate this common area? Okay, we'll first of all draw the common chord. And now, area of this segment will be exactly equal to area of this segment. So we just have to find the area of one of these segments and then just double it. Okay, multiply with 2 to get the total common area. How do we get the area of a segment? We take the area of a sector. Sorry, area of the sector will be this. We take the area of this sector, and from area of the sector, we subtract the area of the triangle. Area of sector minus area of triangle will give us area of the segment. So what will be the area of this sector? Now this sector, it is part of this circle. So we have to find what angle it is subtending at the center of the circle. Of course, this is 90 degrees because this is a square. So area of this sector will be 90 degrees divided by 360 degrees into the area of this circle. Area of circle is pi into radius square. So pi into 1 square. So that will be the area of this particular sector. And from this, we will subtract the area of this triangle. Now this triangle is a right angle triangle. Perpendicular sides are 1. So we will have area of this triangle half into 1 into 1, half into base into height. So now this will give us area of this segment. Okay, but the common area was this segment and also the other segment. Both segments are the same. So to find the total common area of one segment, if we multiply with 2, then we will get the area of both of the segments. Okay, so now we just have to calculate this. So we'll have 2 into pi by 4 minus half. Okay, so that will give us pi by 2 minus 1, which is there in option 2. If you look at this question, two circles both of radii 1 intersect such that the circumference of each one passes through the center of the other. What is the area in square centimeter of the intersecting region? So we'll make the diagram such that each circle passes through the center of the other one, and these are identical circles of radius 1. Now we have to find the area of this intersecting region. Now we know that we'll draw the common chord. Okay, we'll draw the common chord like this. We'll find the area of one of these segments. Area of the sector minus area of triangle will give us area of the segment, and double of that will be the total area. Okay, we've seen that in a previous question. But here the problem is that we don't know the angle that the sector will be subtending at the center. Okay, we don't know the central angle of the sector. So first we will have to find that. So what we can do is, we can first of all connect the centers with the intersection points, and then we can connect the two centers with a straight line. Okay, because both of the circles have radius of 1, so we will get that all of these values are 1. So for example, this is 1 radius of the circle. This is also 1 radius of this circle. Now this is also 1. Okay, you can think of it this way: from the center of this circle to the circumference of the circle, radius is 1. Similarly here, we will get 1 and 1. All of these are radius of the circle. So now we can see that both of these triangles will be equilateral triangles. Both of them, all the sides are equal. So we will get that all the angles are 60. So this will also be 60 and this will also be 60. Okay, so we'll get this central angle here, 60 plus 60, which will be equal to 120 degrees. Okay, now we can find the required area. So first we'll find the area of this sector. Now we have this sector is a part of this circle. This circle radius is 1. Okay, now this sector is subtending 120 degrees at the center. So the area of this sector will be 120 by 360 into area of the circle, which is pi into 1 square. And from this sector, we will subtract the area of this triangle. Now area of a triangle, since we have the angle here, okay, it is half into sine of this angle into sine 120 into the product of these two sides, which is 1 and 1 into 1 into 1. So now from this sector, when we are subtracting this triangle, we will be left with the area of this segment. Okay, and now we will just make it double so that we get the area of the other segment also, and we get the total area. So we'll just take double of this. Now we just have to calculate. So we'll get 2 into pi by 3 minus half into sine 120 into 1 into 1. Now what is sine 120? Sine 120 is the same as sine 60. Sine 60 is root 3 by 2. Okay, so if we calculate this now, we will get 2 pi by 3 minus root 3 by 2. Okay, where do we have that? In option 5. If we take a look at this question, consider a right circular cone of base radius 4 and height 10. A cylinder is to be placed inside the cone with one of the flat surfaces resting on the base of the cone. Find the largest possible total surface area of the cylinder. Let's make the diagram. This is our cone. Now, if we want to maximize the total surface area of the cylinder, let us make the cylinder as large as possible. Let us make it touch the sides of the cone, and let us keep it in the center so that we can make it as wide as possible. Okay, so we'll have a cylinder like this. We'll make it symmetrical so that we are as efficient as we can be and we maximize the surface area. So the center of the base of the cone will be the same as the center of the base of the cylinder. Okay, and now what we can do is we can form right angle triangles and use similarity. Okay, so if we connect the center at the bottom with the center at the top of the cylinder, and we connect them with a straight line which passes through the vertex of the cone. Okay, so that gives us a height, that is the height of the cone. And we can also draw the radius at the bottom here. Okay, and the radius of the top part of the cylinder. So we get right angle triangles, 90 degrees and 90 degrees. And both of these right angle triangles have this common angle. So these right angle triangles are similar. Now, radius of the cone is 4. Okay, so here we have 4. Let the radius of the base of the cylinder be r. Now, the height of the cone is 10. Okay, this total height of the cone, the vertical height is 10. Now, let us take the height of this smaller cone, the height of this smaller right angle triangle to be h. And therefore, the height of the cylinder will be 10 minus h. Now, let us use similarity. So, we can say that radius of the smaller cone, or this side of the smaller right angle triangle, and this side of the larger right angle triangle, they are corresponding sides, r by 4. And also, this side of the smaller right angle triangle and this side of the larger right angle triangle, they are also corresponding sides of the similar triangles. So h by 10. Now both of these are ratio of corresponding sides, so these will be equal. Okay, so now what we can do is we can express h in terms of r. We can get that h is equal to 5r divided by 2. Now if you look at the total surface area of the cylinder, what is total surface area of a cylinder? It is 2 pi into the radius, which is r, radius of the cylinder is r, into r plus the height of the cylinder, into the radius plus the height of the cylinder, and the height of the cylinder is 10 minus h. And this is what we have to maximize. So if we first of all simplify this by by replacing h with 5r by 2. So we'll get 2 pi r into r plus 10 minus 5r by 2. Okay, let us simplify this. So here we have 2 pi r and here we have a 10. Then r minus 5r by 2, that will give us minus 3r by 2. So that will be minus 1.5r. Okay, now we have to maximize this. So let us try to make the sum constant. 2 pi is anyway fixed. Let us make the sum of r and 10 minus 1.5r constant so that we can maximize the product when they become equal. So what we can do is this r, we can multiply and divide by 1.5. Okay, so we will have 2 pi by 1.5 and we will multiply r with 1.5. So 1.5 will cancel off. We will not be changing the value. But the benefit of this is that now if you look at 1.5r and 10 minus 1.5r, the sum of 1.5r and 10 minus 1.5r, if I show you at the side, 1.5r, 10 minus 1.5r, the sum here will be constant. Okay, the sum will be simply 10, which is a fixed number. It is a constant number, doesn't have a variable. And because the sum will be constant, for the maximum product here, we will get the maximum product when the two values are equal. When 1.5r is equal to 10 minus 1.5r. Okay, so that will give us that 3r is 10, so r is equal to 10 by 3. Okay, this value of r will give us the maximum product here. So for this value of r, what is the value of 1.5r? Okay, it is 1.5 into 10 by 3. 3 by 2 into 10 by 3. So that will be 5. So 1.5r will simply come out to be 5. Okay, so now if we just calculate 2 pi by 1.5. 1.5 is 3 by 2. So we'll get 4 pi by 3. And here 1.5r will be 5, so 5. And 10 minus 5, so that will be another 5. So we'll get 100 pi by 3. That will be the answer, option 1. In this question, it has been given that we have a rectangle inscribed in this circle with center at O. The length of side AB is greater than the side BC. The ratio of the area of the circle to the area of the rectangle is pi is to root 3. The line segment DE intersects AB at E such that angle ODC is equal to angle ADE, which has been shown in the figure. We have to find the ratio of AE and AD. So if you look at this diagram, we can see that we have these two angles which are equal, and we know that in a rectangle, the angles of the rectangle are 90 degrees. So if we connect points O and B, okay, then we can see that this right angle triangle AED and this right angle triangle BCD, they are similar. Both of them have a 90 degrees and both of them have a pair of equal angles, which was given. So for these similar triangles, if we use ratio of corresponding sides, see, we have to find the ratio of AE and AD. So AE is opposite the equal angle. Opposite equal angle, we have AE in this triangle. And opposite the equal angle in the other triangle, we have BC. Okay, now, if you look at AD, AD is in this triangle opposite the third angle. We have 90 degrees equal angle and a third angle. AD is opposite the third angle. And in the other triangle here, opposite the third angle, we have DC. So we will get that AE by AD is equal to BC by DC. Now, let us take the length of the rectangle to be L, and let's take the breadth of the rectangle to be B. Okay, so DC will be L, AB will also be L, BC will be B, AD will also be B. So now BC by DC, okay, BC by DC, that will become B by L. So we will get AE by AD, okay, that is equal to B by L. That is what we have to find, the ratio of the breadth and the ratio of breadth to the length. Now, how do we do that? We have to use this information, that the ratio of the area of the circle and the area of the rectangle is pi is to root 3. So area of the circle. Okay, for the area of the circle, we need the radius of the circle. Now, in this right angle triangle, if we use Pythagoras, then we will get the length of DB. And what is DB? DB is the diameter of the circle, chord passing through the center. So DB is the diameter of the circle. And now using Pythagoras, we'll get that DB is square root of L square plus B square. Square root of L square plus B square. So this will be the diameter, which means the radius of the circle will be half of the diameter. Square root of L square plus B square by 2. Now if you use the ratio, area of the circle, it is pi into the square of the radius. So if we square the radius, now if we use this ratio, okay, we have the ratio of the area of the circle to area of rectangle. Now area of the circle is pi into the square of the radius. So we'll have pi into the square of this radius, which will give us L square plus B square by 4. Okay, and this will be divided by the area of the rectangle. Area of the rectangle is simply length into breadth. So this is the ratio of area of circle and area of rectangle, which has been given as pi is to root 3, which is pi by root 3. Pi will cancel off. Now we will get that L square plus B square by LB is equal to, and take 4 to the other side. So we will get 4 divided by root 3. Now we can simplify this. Okay, we can do it this way, that L square divided by LB, separate L square plus B square by LB, write it as L square by LB plus B square by LB. L square by LB will give us L by B. And B square by LB, that will give us B by L. So we can see that these two values are reciprocals of each other. Okay, so now 4 by root 3 also, we can write it in terms of sum of reciprocals of two values. See, 4 by root 3, 4 we can write it as 3 plus 1. 3 plus 1 by root 3. Okay, now if we split it up, 3 by root 3 will be root 3 plus 1 by root 3. Okay, so 4 by root 3 will be equal to root 3 plus 1 by root 3. Now it was given that AB is greater than BC, which means that the length L is greater than the breadth B. L is greater than B. So if we now compare here, okay, we can say that L by B will be greater than B by L because length is greater than breadth. So L by B will be equal to root 3 and B by L will be equal to 1 by root 3. And therefore we will get here B by L is 1 by root 3 and therefore AE is to AD is equal to 1 is to root 3. So the answer will be option 1.